Okay, now in this example, we would like to solve the net electrostatic force on charge Q3. Okay, here is the problem. So this is X and this is Y. As you see, as soon as I write X and Y, you will understand that this is a two-dimensional problem. Here, there is Q1, which is plus 50 microcoulomb. And here we place another charge, Q2. Okay. So this is Q1 and this is Q2. Okay, Q1 is minus 86 microcoulomb. And this is minus, okay, negative. So this is minus charge, and this is plus charge. And then there is another charge. Here, it's Q3, and Q3 is 65 microcoulomb, plus 65. And of course, you can connect this. This is the right triangle. Okay, so these distances are given. This is 52 centimeters, and this is 30 centimeters. Actually, we're not going to use this. This is 0.52 meters, okay? Always convert this into meters, 0.3 meters. So this is the distance we are using. They also give this as 60 centimeter, but it is 0.6 meter. So they also give hypotenuse of this thing, so we don't have to do anything. If you look at this, since this is 30 and this is 60, this is this angle is just 30 degrees. So they give also the angle. We will need the angle to find the components of the forces. Okay. Now let's draw this again. Okay, what is force on Q3? What is that? This is the question. We would like to find the force on Q3. Now here Q3, okay, this is plus Q2, this is minus Q1, and this is plus Q3. Don't forget. Now let's also draw this line. I would like to now draw plus pushes plus, or this produced an electric field in this direction, and because this is positive, the force due to this Q2 is this way. So this is F2. Okay, the force due to Q2 will be this way. Why? Because both of them are positive and they will push each other. Of course, they are pushing each other, but they are not moving. They are stationary. But this is the force that Q3 feels. Okay, but don't you think that Q2 doesn't feel the same force? Of course, it also feels the same force, but we are concentrating on only Q3. What about Q1 and Q3? Because they have different charges, this is an attraction force, so that now the direction of the force will be in this way. Okay, like that. Okay, and then how can we find the net force? Let's write this is F1. Okay, this is force F1. Okay, probably F2 will be longer, okay, a little bit longer, okay, than F1. And now, if we want to get F net, it's going to be, okay, so if you draw a parallel line to this thing and then parallel line to the y direction, the intercept point is this, and obviously you will see that the net amount of the force will be like that. Okay, so this is F net. F net will be above, okay, it will have both positive and positive X and Y components. So don't forget, this is X and Y. Okay, X and Y. Now, F2 is very simple to write. F2 is just K, okay, Q2, Q3 divided by the distance square, which is 0.3 square. And now if you write this in notation, it's vector notation. F2 is in y direction. It's J unit vector, because here is the unit vectors. I is the unit vector in X direction. J is the unit vector in J direction. F2 is given by this. Now, I can write the dimension, the magnitude of F1, okay, without the vector sign, the F1 will be just K, Q1, Q3 divided by, now the distance is given 0.6 square. However, we cannot really use this by itself because F1 has two components, as you see, X and Y components. So I'm drawing this again here. Okay. So now this was F2, but this is F1. Now I moved this coordinate axis here, as you see, and then I'm drawing now here a line, and this is it. Okay. Now I'm not very interested in where Q1 and Q2 are located. Now I'm put my coordinate axis just to the point where Q3 is located. Here is Q3 there. Okay. Now my coordinate axis is drawn. So these are the forces. As you see, F1 has both X components. This F1X and this is F1Y. And the angles are given because this is 30 degrees. Okay, 30 degrees. We know that this is 60 degrees because this is right triangle. Okay, but if this is 30 degrees, this is also 30 degrees. Okay, now it's easy to find out F1X because F1X is just F1 times cosine 30, but F1Y is equal to just F1 times sine 30. Okay, so we can find these values. So if you find the X components, F1 is given by K, Q1, Q3, and this divided by 0.6 square, and cosine 30 is given as square root of 3 over 2, but sine 30 is just 1/2. So if you just take the half of this F1, you will see that it's just, okay, it's just 120. This is 120 Newton. Okay, and Fy, okay, will be, okay, 0. For F2, it's 0. F2Y is 0. F2X is 0 because it has only one component. But F1Y is just the half of it, so it will be equal to F1Y will be equal to, okay, just minus 70 Newton J. Okay, so minus 70 Newtons. We know the direction. So this is F1X, F1Y. Sorry, this is F1Y. This is F1X. Now, if you write F1 as a vector, the X component is just 120I minus 70J. Very simple. Okay, F1 is given by this because the X component is in minus Y direction, but X component is in positive X direction. But F2 was given as before, and the magnitude of F2 is 330, by the way, 330 J. So F2 as a vector is 330 J. Now, if you just add them up, this is what we get, Fnet. So Fnet is just the summation of this. And as you see, there is no X component in the second one, so 120I. Now, 330 minus 70 gives you just 260 plus 260 Newton. Okay, so J, Newton. So this is net force. This is net force. And the magnitude of the net force can be found by, okay, Fnet, or the magnitude of Fnet vector, like this, is equal to just square root 120 square plus 260 square. Okay, so this is how you get the magnitude of this vector, and it is just 290. So Fnet is equal to 290 Newtons. What about the direction? So how can I find this force? What about this? So as you see, if I draw a parallel line to F1 like that, and if I draw parallel line, okay, to F3, okay, so F2 is this way, and if you just draw a parallel line from the tip, as you see, you will get this Fnet force and this is the angle that we are trying to find. So now, if you look at this Fnet, this is Fnet, okay, vector. It has both positive components. This is F. This is 120. Let's write the values. 120, and Y component is 260. This is the angle that we are trying to find. Very simple. If we get tangent alpha, okay, will be equal to 260 divided by 120. 260 divided by 120. So whatever the value it is, you can find this as by taking the arc tangent. Okay, arc tangent, this value. You can find this angle, and it is found that if you put these values in, you find that this is just 65 degrees. Okay, this is the end of the second example, two-dimensional example. Now we stop recording.